This is the beginning of section 2.5, and it is more on graphing of linear equations. And there are four key objectives. One of them is graphing linear equations using intercepts. And then given a linear equation in slope-intercept form, we use the slope and the y-intercept to graph the line. And then we graph the line, linear equation of the form x equals a or y equals b, and then given the equations of two lines, determine whether their graphs are parallel or whether they are perpendicular. So we will learn all of that in this section here. So we begin with the idea of x-intercepts and y-intercepts. We talked about the y-intercept already, but how do we actually compute these intercepts? So when we have an equation in two variables, the y-intercept is the point 0, b. And to find b, we let x equals 0 and then solve the equation for y. And for an x-intercept, it's the point 0, a, 0. And to find a, we set y equal to 0 and then solve the equation for x. So if that sounds a little bit confusing, don't worry about it. Once we do an example, it'll be pretty straightforward. But it is important to remember how we find x and y intercepts. So let's apply these principles of finding x and y intercepts. Here's the first exercise. Find the intercepts of 4y minus 12 equals minus 6x, and then graph the line of this equation. So to find the y-intercept, we set x equal to 0. So that means 4y minus 12 equals minus 6 times 0. That, of course, is equal to 0. Now we add 12 to both sides. So 4y equals 12. We divide both sides by 4, so y equals 3. So the y-intercept is 0, 3. Again, the 0 comes from the fact that we set x equal to 0. That's where that 0 comes from here for the y-intercept. Then, to find the x-intercept, we set y equal to 0. When we do that in the original equation, that means 4 times 0, minus 12 equals minus 6x, or minus 12 equals minus 6x. When we divide both sides by negative 6, minus 12 divided by minus 6 is equal to 2. So then the x-intercept is 2, 0. So when we plot these 2 points, the x-intercept at 2, 0, that's our x-intercept, 2, 0. Again, notice that for x-intercept, the y-coordinate is always 0. Just like for y-intercept, 0, 3, the x-coordinate is 0. This is 0, 3. So based on the x and y intercepts, we can simply draw a line, and this represents the equation 4y minus 12 equals minus 6x. So using intercepts makes graphing an equation very easy. You can almost do it in your head. And so that's one of my favorite methods of graphing the equation of a line. And now the next few graphs are a little bit different. They don't use intercepts per se, but we now talk about graphing using the slope and the y-intercept. So an example exercise, in the following exercise here, it says graph using the slope and the y-intercept. And the equation is y equals 3/2 x plus 1. Now remember what 3/2 means. it's rise over run. And this number 1 is the b part of the y-intercept 0, b, so the y-intercept is 0, 1. So we use that as a starting point for graphing our line 0, 1. That would be right here, the y-intercept. Now rise over run, 3 divided by 2, that's the rise, and that's the run. So that means we go up 3, 1, 2, 3, and then that's our rise, 1, 2, 3 up, and then the run is 2, so we go 2 to the right. So here's the other point, and what we do now is we graph a line through these 2 points. So again, we use the y-intercept 0, 1 as our starting point. We go up 3 units because it's 3 for the rise and 2 to the right because the run is positive. And that's the point 2, 4. We graph a line through these 2 points, and that represents our equation y equals 2/3 x plus 1. So here's y equals 3/2 x plus 1. The next exercise is very similar. It says f of x equals 3/2 x minus 2, 3/4 x minus 2. So our y-intercept is 0, minus 2, and rise over run, our slope is 3/4. So that's the rise, and there's the run. And the point 0, minus 2, of course, is here. And so we go up 1, 2, 3 units, and 1, 2, 3, 4 units to the right. So this is our second point here. And this was our first point, the y-intercept. And now all we do is connect these 2 points with a straight line. As in the previous example, we start at the y-intercept, and again, based on the slope, 3/4, 3 meaning the rise, we go up 1, 2, 3, and then the run is 4, positive, so we go 1, 2, 3, 4 to the right. Here's the second point. We connect these 2 points with a line, and that's now the graph of y equals 3/4 x minus 2. In the next exercise, we have g of x equals minus 3/5 x plus 5. So again, for the y-intercept, we have 0, 5 as our starting point, and now the slope is equal to minus 3/5. Well, we can write that as minus 3 divided by 5. Of course, we could also write it as 3 divided by minus 5, but in this case it really works out better if we do it this way, and you see in just a moment why. So when we begin at our y-intercept, 0, 5, that's our starting point. So the minus 3 tells us for the rise, we go down 3 units, 1, 2, 3. Okay, and that gets us to this point here. And the 5 tells us we go 5 units to the right, 1, 2, 3, 4, 5. So that would be the second point. So we have a negative rise of 3 and a positive run of 5. So now all we need to do is connect these 2 points, and that'll be the graph of g of x. So now here we have the graph of g of x, where we started at the y-intercept, 0, 5. We had a negative rise of 3, a positive run of 5. Here's our second point. We connect the line, the 2 dots with a line, and that's the graph. Now, what I've done here is I use the principle that minus a divided by b can be written also as minus a divided by b. and it can be written as a divided by negative b. And so it depends. In other words, this fraction could have been written as 3 divided by minus 5. The problem is that with this approach, starting at the y-intercept, going up 3 would have gotten of the graph of the coordinate system here. And that's the reason I chose minus 3 divided by 5. Again, 3 divided by minus 5 is mathematically the same thing, but for graphing purposes, this one works better. Okay, then there's the next one, and that says, and identify the y-intercept and graph the equation. From looking at this term here, minus 4 means our y-intercept is at 0, negative 4. And our slope is equal to minus 5 divided by 3. So we have our starting point at 0, minus 4, which is here. Now, we can write this as minus 5 divided by 3, but minus 5 means we have to go down 5, and that means we are off the coordinate system here. So it would probably be better to write this as 5 divided by negative 3. Because now we go up 5, 1, 2, 3, 4, 5, it gets us to this point. And minus 3 means we go 3 to the left, so minus 1, 2, and 3. So here's our second point. So now all we need to do is to connect these 2 points here. And that'll be the graph of y. So to recap exercise number 5, we started at the y-intercept of 0, minus 4 at this point. We chose to write minus 5/3, our slope, as 5 divided by negative 3. That allows us to go up 5 units and 3 to the left, 5 up and 3 to the left, which gives us our second point. And then we connect these 2 points with a line. And that's the graph of y equals minus 5/3 x minus 4. The next part is about some special type of lines. That's horizontal and vertical lines. So here we are supposed to graph the line, or the equation y equals 3. So since x is missing, any number for x will do. Thus all ordered pairs x, 3 are solutions. So the graph is a horizontal line parallel to the x-axis. For example, if we choose x equals minus 1, y equals 3. It doesn't matter what x is, y is always equal to 3. So x is 0, y is equal to 3. If x is equal to 2, y is equal to 3. If x were equal to 100, y is equal to 3. So we plot these points and draw a line through them, and then we have our graph of y equals 3. It's a very simple thing to do. So when we look at exercise number 6, it says f of x equals minus 4. So it means no matter what the value of x is, the function value is negative 4. So in other words, negative 4 here and negative 4 there, or anywhere we choose f of x equals minus 4, so it means we simply connect these points here, and it's the line to the point at the y-axis of minus 4. So for number 6, f of x equals minus 4 is simply a horizontal line through y equals minus 4. Similarly, exercise number 7, we are told that the y is equal to 3.6, and that means we look for 3.6. It's approximately here, and it's simply a horizontal line parallel to the x-axis through the point 3.6. So as you can see, horizontal lines are easy to understand and easy to graph. In example 5, we are asked to graph the equation x equals -2. So, since y is missing, any number for y will do. Thus, all ordered pairs -2, y are solutions. And the graph is a vertical line parallel to the y-axis. So, when y is equal to 0, x is equal to -2. When y is equal to 3, x is equal to -2, etc. So we have a line through these ordered pairs here, and this is the graph of x equals -2. So vertical lines are also very easy to graph. Now here's an important little note. This graph is not the graph of a function. Why? Because it failed the vertical line test. The vertical line itself crosses a graph more than once. So in other words, a vertical line takes up the whole line, which means it crosses it more than once, and so that is why this is not the graph of a function. In the next exercise, we are asked to graph x equals -5. Well, just as in the previous exercise, number 5, it's simply a vertical line to the point x equals -5, and since -5 is here, all we have to do is graph a line vertical, in other words, parallel to the y-axis. So here's the graph of x equals -5, parallel to the y-axis to the point x equals -5. The next exercise says 8x minus 5 equals 19. And they even give you a little hint. Solve for x. Well, we know how to solve this equation for x. We add 5 to both sides. That isolates the expression with a variable. And 5 plus 9, 19 is 24. We divide both sides by 8. And 8x divided by 8 is x. And 24 divided by 8 is 3. So this then is the line, the vertical line to the point x equals 3. So we started with the original equation 8x minus 5 equals 19. We developed that into an equivalent equation x equals 3. And here's a graph of the original equation 8x minus 5 equals 19. To the point x equals 3, a vertical line parallel to the y-axis. The following summarizes the characteristics of horizontal lines and vertical lines in the equations. The graph y equals b, or f of x equals b, is a horizontal line with y-intercept 0, b. It is the graph of a constant function with slope 0. All these points are important. Horizontal lines have slope 0, we know that. And then the graph of x equals a is a vertical line with x-intercept a, 0. The slope is not defined. It is not the graph of a function. So you definitely want to remember and memorize these points about horizontal and vertical lines. So the next few exercises are pretty straightforward here. 10a, x equals minus 12. So we know that's a vertical line. And so for a, slope is not defined. For the b part, y equals 6. Well, that's a horizontal line. So the slope equals 0. And 2y plus 7 equals 11. Again, when we solve that equation, we come up with a number y equals 2. And we know that that's a horizontal line also. So for c, the slope equals 0 because it's a horizontal line. For D, x equals 0, that's a vertical line. In fact, it is the y-axis, and so we can say that slope is undefined. Slope is undefined. And E we know is a horizontal line. It's y equals a number. So the slope is 0. And for F, we can solve this equation for x equal to -1. And we know that's a vertical line. So we know for F, the slope is undefined because it's a vertical line. Slope is undefined. Next, we talk about lines that are parallel. And so here the definition is that two non-vertical lines are parallel if they have the same slope and different y-intercepts. And then by definition, vertical lines are parallel. Here we cannot really talk about the slope of two vertical lines because remember the slope of vertical lines is undefined. So let's look at the exercise number 13. Determine whether the graphs of the given pair of lines are parallel. Well, here's the two equations. X plus 4 equals y, and y minus x equals -3. So the key to answering this question, to see if they're parallel or not, is to rewrite each equation in this slope-intercept form. Okay, so the first equation, x plus 4 equals y, becomes, simply turning it around, y equals x plus 4. And solving this equation for y, we simply add x to both sides. So then we get x minus 3. Y equals x minus 3. And so the slope of each line is 1. There is no 1, but we know that x is the same as 1x, so we can say that the slope of each line is equal to 1. And the y-intercepts are 0, 4 for the first one, and 0, -3 for the second one. So therefore, we can say that the lines are parallel because the two conditions are satisfied. Number one, they have the same slope, and they have different y-intercepts. So they are parallel. And then number 12, it's the same situation. We solve each equation for y. So in this case, y equals 3x. And now we subtract 4 on both sides, so that becomes 3x minus 4. And this equation we solve for y. So we subtract 4x on both sides, so then y is equal to 4x plus 7. And even though the intercepts are different, the slopes are different also. So that, first of all, tells us the lines don't even have the same slope, so they are not parallel. And number 13, well, here we already have the first equation in the form y equals mx plus b. And so to solve this one for y, we simply divide by 2 on both sides. So then that becomes the y equals, and 8 divided by 2 is 4, so 4x. And 10 divided by 2 is 5. So now we see that these two lines are really identical. Y equals 4x plus 5 and y equals 4x plus 5. In other words, they have the same slope, but they also have the same intercept. So that means they are not parallel. So these two equations really represent the same line. And a little while ago I said that the slope-intercept form of the equation is a very, very important form of the equation, and I'm sure by now you can understand why that is so, because it has a lot of information in it about the slope and the intercept, which among other things allows us to determine whether two lines are parallel or not. We're closing section 2.5 with looking at perpendicular lines. So here's the definition. Two lines are perpendicular if the product of their slopes is -1. In other words, if one line has slope m, then the slope of the line perpendicular to that line is -1 divided by m. That is, to find the slope of a line perpendicular to a given line, we take the reciprocal of the given slope and change the sign. So lines are also perpendicular if one of them is vertical, like of the form x equals a, and one of them is horizontal, y equals b. So horizontal and vertical lines are perpendicular. So here we are supposed to find out whether the graphs of the particular pair of lines are perpendicular. So again, we want to rewrite the equations in slope-intercept form, so we can determine immediately what the slope is. So we write each equation, 2y minus x equals 2 and y plus 2x equals 4. So we write them in slope-intercept form, and then the first one becomes y equals x plus 2. We 1 have x plus 1. We divide by 2 on both sides. And the second equation, we subtract 2x on both sides. So y equals 2x minus 2x plus 4. And so the slope of these lines are as follows. They are 1/2 and -2, and the product of 1/2 times -2 is -1. Therefore we can say the lines are perpendicular. So these two lines are perpendicular. And again, just some looking at the slopes. And again, that form of the equation, y equals mx plus b, has so much information, and it helps us answer the question, are two lines perpendicular? And then the last exercise is number 15. 3y equals 2x plus 15, and 2y equals 3x plus 10. So let's take the first equation and solve it for y. So that we can, by dividing both sides by 3 to isolate y. So y is then equal to 2/3 x plus 15 divided by 3 is 5. And here we divide both sides by 2. So y equals 3/2 x plus 5. 10 divided by 2 is 5. And so the slope of the first equation is 2/3. Let's say that's the slope m sub 1 is 2/3. And the slope of the second equation, let's say it's m sub 2, is equal to 3/2. And when we take the product of the slopes, m sub 1 times m sub 2, that would be 2/3 times 3/2. And that's equal to +1. For these two lines to be perpendicular, the product of the two slopes has to be negative. So we can say They are not perpendicular. Not perpendicular. This is the conclusion of section 2.5.